Hi guys, welcome to Scholastic Home Video Tutor. In this lesson, we are going to look at confidence interval. In particular, I'm going to take a question from AQA Mathematics Unit Statistics 1B, January 2011 examination, question number 3, which is a GCE-AS level examination. Let's try to go through the question first. Question number 3. The volume X liters of orange juice in a 1 liter cartoon may be modeled by a normal distribution with unknown mean mu. This is the mu. This mu is the population mean. Population mean. And the volume X liters recorded to the nearest 0.01 liter in a random sample of 100 cartoons. They take a sample of 100 cartoons and it's shown in the table here. So they are given in classes like the volume between 0.95 to 0.97. There are 2 cartoons like that. There are total 100 cartoons. So what we are asked to do here is to, for the group 0.98 to 1.00, show that it has a midpoint 0.99 liters. We'll come to that one soon. State the minimum and the maximum value of X that could be included in this group. Calculate to 3 decimal places estimates of the mean and the standard deviation of these 100 volumes. So basically we had to estimate the standard deviation and the mean by using these class values, and construct an approximate 99 confidence interval for mu. Mu is the population mean. By taking a sample of 100 cartoons, we can actually estimate a confidence interval for mu. We'll come to that one. State why use of central limit theorem was not required when calculating this confidence interval. So we'll state a statement for that one. Give a reason why the confidence interval is approximate rather than exact. Give a reason in support of the claim that mu is greater than 1. Also the probability that X lie between 9.94 and 1.1c is approximately 1. Okay, that's the question. So let's go through each part one by one. So question number 3. Part A, Part 1. Part A, Part 1. So we are asked to find out the midpoint of the class here. So it is quite straightforward. Midpoint is equal to the minimum point of the class plus the maximum point of the class divided by 2. So which will give us the value of the midpoint 0.99. Also, you can think of it a little bit broadly. Basically, in this case, we took the exact 9.98 to 1.00, but in this class, actually, there are values which can start from 0.975. That is the range between 97 to 98, the midpoint of 0.97 to 0.98. Also, it can go up to 1.005. So, because this is the midpoint between 1.00 to 1.01. So therefore you might also can use midpoint is equal to 0.975 plus 1.005 divided by 2, which is equal to 0.99. Same answer there. So that is the other way of calculating the midpoint. Okay, that's the answer to part 1. So part 2, state the minimum and the maximum value of X that could be included in this group. So question number 3, part A, part 2. So we have seen that this range can have values lower than 0.98. So the lowest value that can contained in this range is the minimum value, is the value in between 0.97 and 0.98 divided by 2. So midpoint of the range between the two classes, which is equal to 0.975, which we have already seen earlier. Also, we can find the maximum value. It will be, so we have 1.00 and 1.01, so it will be 1.00 plus 1.01 divided by 2, which will be equal to 1.005. That is the maximum value. Also, you might argue that if you put 1.005, it actually can go to the next class, because we always assume 1.005 belongs to the next class. So maybe if you want to make it precise, you can write the answer to this one is equal to 1.00499999. So this may be is a much precise answer. So let's see the next part of the question. Part B. Calculate to 3 decimal places the estimates of the mean and the standard deviation of these 100 volumes. So now our question is to use this table, and there are 100 of them here, and there are classes. But when you want to consider these classes, we need to find out the midpoint before we start entering the values into a calculator. Before we enter into the calculator, we need to calculate the midpoint of these classes. So the starting from here, we need midpoint of 0.9596, 99, 1.02, 1.05, 1.08, 1.11, 1.14, 1.17. So these are the midpoints of these classes. And now let's open a calculator to enter these values. So please check whether you can open your calculator and then go to the statistics mode. In my calculator is number 6 here, and one variable, there's only one variable x there, so with a frequency, so we can see x and a frequency. So you need to find out how to get to this mode in your calculator, which is the x and frequency. So I'll just bring it here and keep it here when I enter the values. So what I'm going to do is I'm going to enter the values, 0.96, enter. So these are the x values I'm going to enter, then frequency later on. So frequency is still 1 here, but we'll come to that one again. 0.99, enter. 1.02, enter. 1.05, enter. 1.08, enter. 1.11, enter. 1.14, enter. 1.17, enter. These are the 8 values given in the x column of the table, and the frequency column, we need to enter the frequencies for each midpoint of the class. So our frequency is 2 for the first one, enter. 7, enter. Please make sure you are entering it in the correct row. 1.02 is equal to 15, enter. 1.05 is equal to 32, enter. 22, enter. 14, enter. 1.14 is 7, enter, and 1, enter. So there are 8 values, so you have entered all the values there. So now our task is to calculate the mean. So you go to, in this particular case, I go to options menu and then number 3 for the values of the calculator. So this basically, I can see the mean, estimated mean of those sample values is x bar 1.062, and the standard deviation is 0.0 sigma is the standard deviation, 0.04263801112. I'll take them into the PowerPoint slide here. So basically we have those values. So the answer to this question is that x bar, or the estimated mean, estimate of mean x bar is equal to 1.062, and the standard deviation sigma is equal to this value sigma. So this is the answer. So put 0.0426, we make it 3, that is the approximation to 3 decimal points. So these are the two answers required for part B. Calculate to 3 decimal places estimate of the mean and the standard deviation of these 100 volumes. So we will need these two values for the next part of the question. Basically we need to construct approximate 99% confidence interval for mu. Mu is the population mean, and what we found out is actually this is the sample mean. So using sample mean we can have a approximation for the population mean, which is mu. Let's see how we're going to do that one. So basically I'm going to explain a little bit of theory here, confidence interval. So let's write them in here. So what we have here is a population mean of is mu, and take 100 samples. That means our n equal to 100. So we have a population mean of mu, and we need to estimate the population mean by using the samples you took to a confidence of 99%. Basically what that means is that the probability of having mu for 99% confidence, we can say that 99, that means this is the total probability should be 1. So but the value of mu will lie in this region, that is 99% region. So we need to find out what is the what is the range for mu to get it 99% accurate. So when it is 99% area here, so that means total area is 1. So we have one area here, one area here. So this is 99 as a ratio. So therefore this area, small area here, is equal to 0.005, and this one 0.005. So that means there are two equal areas divided into each side. So when you add them, you get 0.01. So what we need to find out is the value of Z here, which will satisfy the equation x bar. Basically the confidence interval of mu is equal to x bar plus or minus Z times sigma over root n. This is an equation given. You need to remember this one. So once you know this equation, we can plug in the values for Z. Sigma is actually, or we have calculated for the population mean, is the population standard deviation, and the number of samples you took 100. So to get 99% confidence for the value of mu, we can find out the range. That means x bar is actually, we calculated x bar from the previous section, which is equal to 1.062, and we calculated sigma, which is equal to 0.0426, and we also know n is equal to 100. So what our task next is to find out the value of Z that will satisfy this condition. So that means the area from here to here to here to here, this total area, if I add all this should be equal to 0.995. Please note that, because if I just go to our formula table, so if you open up your formula table which will be given in the exam, so you can see that there is a graph, there's a table number 4, percentage points of the normal distribution. In that you can see that the curve here, the probability up to here is P. So exactly that what we saw here, when that probability is 0.995, what is the value of Z? That is what we need here to calculate the confidence interval for mu. So how are you going to find Z? So you go to the table and then go down to the value of P, 0.995. So 0.995 is this value. That is the value of Z. So once we know the value of Z for the confidence interval of 99%, then we can plug in the value here to find the interval. So that means confidence interval of mu, which is equal to x bar 1.062 plus or minus Z is equal to 2.5758 times sigma 0.0426 divided by root of n is root of 100. So that's all you have to do. Basically, to find the confidence interval for a given percentage, if it is 99%, you saw that 99% is the center value, and then there are two tails. So you divide the remaining 0.01 to two sides, and then you got 0.005. And then when you refer to the tables, you have to add that 1 to 99%. That's a very important thing that you should do. You have to add 0.05 to 0.99. So therefore we have to look at the value 0.995 in the tables. If it was 95%, you will get 0.025. Then you look at 0.975 in the tables. We'll come to similar question later on. So what we can do is we just simplify this one and find out the confidence interval is equal to, therefore confidence interval equal to 1.051 to 1.073. By using a calculator you can calculate these values. So that is the confidence interval, 99% confidence interval of the population mu, because population mu is unknown. So what you do is you take 100 samples and try to estimate what that can be. So that equation, this important equation here, you should remember this one. So use that equation to calculate the confidence interval. Okay, so hope you got the point there. So let's go to the next section. So in this case what we do is to state question number 3, part C, part 2. So it is asking why state y use the central limit theorem was not required when calculating this confidence interval. So please look at the question. So it is already stated that the probability or the population is a normal distribution. So it's already stated there. So this population may be modeled by a normal distribution. So therefore population is modeled by normal distribution. So actually it's already modeled by normal distribution, therefore we don't have to use the central limit theorem. Therefore central limit theorem is actually, we will come to that one later on. So basically it says that if you have any kind of distribution, it may not be normal distribution, but it can be any kind of distribution. But once you take a random sample of that distribution, if you calculate the values of mean of that sample, random sample, those mean will lie in a normal distribution. All the values of the mean that you calculate from the previous population will lie in a normal distribution. So there is a different condition. We'll come to that one later on. So part 3, it says that give a reason why the confidence interval is approximate rather than exact. In this case, what we saw was that the values are, since the values are grouped values, therefore the estimation reason why the confidence interval is an approximation. So we can't actually exactly tell what is the confidence interval, because our values are already grouped. So if it was exactly given like volume 0.96 is this much, 0.98 is this much, so we can say it's not a approximation. Okay, let's go to the last part of the question, part D. In this case, we are given that the claim is that mu is greater than 1. So question number 3, part D, part 1, it says that mu is greater than 1. So how are we going to tell this claim is correct? So when you have a claim like that, so we need to check what we did earlier. We got a confidence interval of mu, which is equal to 1.051 to 1.073. So mu is greater than 1.105. So the lowest value of mu, is 1.051, which is greater than 1. Therefore, we can say that mu is greater than 1. So lowest value of mu is the confidence interval is greater than 1. So that is the answer to question part 1. The last part is here, question 3, part D, part 3. So we are given the probability of x lying between 0.94 to 0.16 is approximately equal to 1. So what is this claim? How are we going to show this claim is correct? So when you look at the table here, so we can see that there is only one value greater which lies outside this range, 0.94 to 1.16, so 1.18. So this one may also, there's a probability that this one may be 1.16, because it's so this value can be 1. Because this class can go up to 1.155. So if that is the case, this may be a value which will be in this range, 1.16. So it is less than 1.16. So there is a possibility that all values will be in this range, but approximately, therefore we can say, since there is only one value outside the range, we can say the probability of 0.94 less than x less than 1.16 is approximately equal to 1. That is the final answer. Thank you.